Hello and welcome to lesson 2.1 on solving one-step equations. So today we'll be reviewing how to solve a one-step equation. An example here is shown, negative 7m equals 56. I'm trying to figure out what the variable m is. So negative 7 times what is going to give us 56? Well, I know a negative times a negative will be a positive, so I know my answer must be negative. And 7 times 8 is 56, so my answer is negative 8. So that's just one example here to kind of get you started on what we're doing. We're solving for an unknown variable. Most of the time that variable is x, but it can really be anything that we want it to be. So when I'm looking at, sorry, a little out of order here. So when I'm solving one-step equations, our main goal is to isolate the variable. An example, x plus 2 equals 10. I want to get that x by itself, isolate it. To isolate it, I'm going to perform inverse operations. Inverse operations are just those operations that undo each other. They're the opposites. So what is the opposite operation of addition? Well, that would be subtraction. If I'm going to undo adding something, I'm going to subtract. I could add $10 to my wallet, and then my wife will quickly subtract that amount. So she'll undo that. The undoing of subtraction would be to add or addition. Multiplying, undo that is division. And to undo division, we multiply. So it's just kind of those opposite operations of addition is subtraction and multiplication is division. And those work both ways. So to put out a fire, we use water and so on. So when performing your inverse operations, remember to keep your equation balanced. We're always looking at balancing our equation, so whatever we do to one side, you need to do to the other. So if I'm on the left here, you can see right now I have 2 big blues and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 yellows, and the same thing holds true over here. So if I was to take away a blue, I'm unbalanced, so whatever I did to this side, in order to balance it, I must do it to this side. So if I added on, if I subtracted a couple of, let's say 3 yellows, I would need to do the same thing to this side to even it out. So I could subtract a yellow, but if I subtract a blue, I'm still not balanced. So I need to keep that balance in order to maintain my equation. I'm always balancing my equations. So we're going to look at a couple of different examples of one-step equations, adding and subtracting. First, and then we'll look at some multiplication and division problems here momentarily. So let's take a look here. Our original equation is x minus 3 equals 5. And I'm solving for x. So, excuse me. So I'm asking myself, what number minus 3 is 5? So some of you might be saying to yourself, well, that's easy. It's 8, because 8 minus 3 is 5, and you would be correct. But in order to kind of work this out and show our steps, we ask ourselves, well, what is the opposite of subtraction? And remember, we need to keep it balanced. So the opposite of subtraction is to add. So instead of subtracting 3, I want to add 3, because I'm trying to get x by itself again. So whatever I do to one side, I do to the other. So minus 3 plus 3 is just gone. So I have just on this side of my equation, I have x. And what do I have over here? Well, I have 5 plus 3 is 8, so x equals 8. To verify that answer, or to check it, I can take this value for x and plug it back in, and I ask myself, 8 minus 3 equals 5, and that's a question. Is that true? Well, 8 minus 3 is 5, and 5 equals 5, so I'm happy. I got it right. So I know that x is equal to 8. That's the nice thing with solving equations, is that I can always go back and verify my answer and check to see that I got the correct answer. I don't ever have to kind of just hope that I did or anything else. I can always verify my answer. So x plus 6 is 10. So what number plus 6 is 10? So as I work through this problem, the opposite of addition, I'm going to need to subtract 6 from both sides. Leaves me with just x. And what is 10 minus 6 is 4. So is 4 plus 6 10? and 4 plus 6 is 10, and 10 equals 10, so I know I have the correct answer there. So pretty straightforward. I will tell you that in this unit, we're beginning with one-step equations, but we'll be moving to multi-step variables on both sides. So this is just really the foundation for where we're going in this module. So here are some problems for you to practice. If you could please take a moment and try these on your own. And we'll check back in with you. Number 6 is a fraction here, so just be careful of that. They do have the same denominator, so it should be pretty easy when you're solving that one. So please pause at this time and check and complete these problems, and we'll verify them here momentarily. All right, hopefully you've had enough time and you were successful in what you were doing. So let's take a look here. I'm solving for the variable x in numbers 1, 2. I'm looking for a here, y, and n. And one thing I forgot to mention before, it was just it happened that all my variables were on the left side, but I always want to write my answer x, or whatever the variable is, equals. I don't want to write that some number equals x. I don't like that. Because we're interested in knowing what the variable is, so all of our answers need to look like the variable equals and then the quantity or the amount that it is. So let's take a look here. So what number plus 5 is 10? Well, I think I have an idea of what our answer is, but let's just work through it. So I do the opposite operation of adding, would be subtracting 5. So that leaves me with x, and 10 minus 5 is 5. What number minus 6 is negative 9? This one doesn't really jump out at me as having as the answer right away, so I'm just going to perform my opposite operation. So instead of subtracting 6, I'm going to add 6 to both sides to get rid of that minus 6, get x by itself. And negative 9 plus 6, so remembering back, I'm at negative 9. I'm adding, which means I'm moving in this direction. I'm moving in that direction 6, so I'm at negative 3. Negative 3 plus a equals 7. So I don't necessarily need to look at this sign. I'm more looking at this value here. How do I get rid of a negative 3? Well, I need to make it a 0, because that's negative 6 and 6 make 0. 5 minus 5 is 0. So I'm going to add 3 to that. I'm looking at the sign that's right in front of it, which is a negative. That leaves me with just an a, and 7 plus 3 is 10. So my answer there is, sorry about that, is a equals 10. Let's look at number 4 here. So I have y plus 2 equals negative 9. I'm going to subtract 2 from both sides. And y equals negative 9. Take away 2 more, makes it negative 11. Y minus a negative 9 equals 5. So I have a minus a negative. So what I'm going to do is just remember that when I'm subtracting a negative, that's really the same thing as adding. So I can just kind of make that a big plus sign. So I'm going to rewrite my problem as y plus 9 equals 5. And subtract the 9 from both sides. So y equals 5 minus 9 is negative 4. When I go back, and I'm going to use my calculator, I'm going to plug it in and say, does negative 4 minus a negative 9 equal 5? And yes, it does. And I kind of warned you about this one ahead of time to watch this this fraction, but we can still work this out just the same. So I'm going to add 3/4 to both sides to get rid of that minus there. So n equals, well, 1/4 plus 3/4 is 4/4, which is just 1. So n equals 1. Any 4/4 or 1, 1 would be the preferred answer, but 4/4 is acceptable as well. So hopefully you were very successful there. Let's take a look here and solving some one-step equations involving multiplying and dividing, so multiplication and division. So let's look at our first problem here. Our original equation is 3x equals 15. So 3 times what number is 15? In order to do this, to show our work, we're looking at, well, what's the opposite of multiplication? And that's division. So I'm going to divide both sides by 3. That's just how I'm going to write it. 3 over 3 just becomes 1, so that leaves me with a 1x, and that's why that works like that. I don't have to write the 1, but you can kind of see the 1 there as I cross those out. And 15 over 3 is 5. So once again, can I go over here and verify, do my little check and verify that my answer works? So does 3 times 5 equal 15? This is a question. And 15 equals 15. So I'm happy that I got the right answer. Alright, let's take a look here at number 2, our second one here, and we're given the problem x divided by 6 is equal to 10. So what number divided by 6 is 10? And as I'm solving this, working this out, what's the opposite of division would be multiplication. So I'm going to multiply both sides by 6. I don't know why I wrote a 5. Let me just erase that and kind of start this one over. So I'm going to multiply by 6. So multiply both sides by 6. Those cancel out because I have 6 over 1. So really to work this out, just to show you, is 6x. Because I'm multiplying by 6 over 1. And 1 times 6 is 6. The 6's are gone, just like above, so I'm just left with x. So x equals, and 10 times 6 is 60. So x is 60. So just to verify, is 60 divided by 6 10? And the answer is yes. Alright, so here are some problems for you, your turn. So there's 6 problems here for you to try. If you could please pause the recording at this time and try these 6 problems. I'll be back with you shortly to go verify your answers. Alright, hopefully you found these pretty straightforward and easy to solve for x or to verify your answer. So once again, just kind of ask yourself, well, what number times 3? 3 times what number is 21? And let's just do this. This is a multiplication problem. So I'm going to divide both sides by 3. Those are canceled, so x is 21 divided by 3, which is 7. W divided by 4 equals negative 10, so that's a division, so I'm going to multiply both sides by 4. Those are gone, so W equals negative 10 times positive 4 is going to be a negative. 10 times 4 is 40. Negative 3 times G equals 27. So I have a negative times something is a positive, so I'm already thinking to myself, well, my answer better be negative, because I know a negative times a negative will give me a positive. But this is a multiplication, so I'm going to divide both sides by negative 3. So those cancel, so I'm left with G equals positive over negative is a negative. 27 over 3 is negative 9. So G equals negative 9. Let's take a look here. D divided by 5 is 15. I'm going to multiply both sides by 5. Those cancel, so D is equal to 15 times 5, which would be 75, I believe. Let me just verify here. 15 times 5. Gotta work this out, so 5, carry that, yep, 75. So D equals 75. A common answer here would be 3. Any ideas on why that common answer might be 3? You're right, because 15 divided by 5 is 3, so doing the wrong step there might give us the wrong answer. Dividing by 5 instead of multiplying would give us 3 as an answer. But if you were to verify that, does 3 divided by 5 equal 15? And the answer is no. So just following through with your check and verifying your answer like that would make sure that you have the correct answer. And let's do one more here. We have 2 more problems, so let's do another multiplication here. 8 times y, so I'm going to divide both sides by that 8. Left with y equals, I have a negative over a positive, which means my answer will be negative. 64 divided by 8 is 8. And we know that a positive times a negative will give us a negative, so we're on the right track, and 8 times 8 is 64, so that works out. And the last one here, 2/3 x equals 10. So 2/3 of what number is 10? Well, I kind of have a multiplication and division here, so I just need to do the inverse of that, which would be 3 over 2. And I have 3 over 2, so those cancel, so I'm left with x equals 30 over 2, which is 15. So x equals 15. That is the end of today's lesson. Please make sure that you watch the remaining videos, you complete your homework assignment, and you do your review or before you do your practice quiz for this unit. If you have any questions, please contact your teacher directly. Thank you.